In this online lecture, we're going to talk about how carbon could make triple bonds. In this particular layout, the bottom bond here would be the sigma bond. This would be a pi bond right here, and this would be another pi bond. And the bond on the left would be a sigma bond. So the question is, how does carbon make these bonds? And think about this. We saw in a previous online lecture that in order to make a pi bond, you had to have an unhybridized p orbital sideways overlap with another p orbital. And if this carbon has two pi bonds, then you should be thinking he probably needs two unhybridized p orbitals. Well, let's take a look at that. Just like we saw before in a previous online lecture, we're going to have to rearrange carbon's orbitals in order to get this type of bonding. And of course, we're going to be concerned with only the valence shell of electrons. And what we have to work with here, remember, is the s orbital and the three p orbitals. And let's do this. Let's remove our electrons here, get them out of the way. So remember, in order to get those two pi bonds, in this case, we're only going to want to hybridize one s orbital and one p orbital, leaving two p orbitals unhybridized. And our hybridized orbital here on the left is going to be half s and basically half p. We're going to cut him in two equal parts here, and we're going to end up with two hybridized orbitals that look like this. Notice these are the most spherical out of sp3 and sp2 hybridized orbitals, simply because they have the most s character. Or we can say these orbitals have the highest percentage of s character because they're 50% s, whereas in sp3 hybridized orbitals, they're only 25% s. So let's see what happens here to the electronic configuration of carbon. This is our new layout here, which means these sp orbitals right here are these sp orbitals here, and the two unhybridized p orbitals right here are these right here. And of course, let's put the electrons back, one in each orbital here. And what we have is the electronic configuration of an sp hybridized carbon. So here's what we need to remember for our next Orgo exam. This is the unhybridized carbon electronic configuration with his diagram right here. And in this case, we're sp hybridizing him into a new carbon that still has his 1s orbital unhybridized. So let's put that down here. But now we have the new sp hybridized orbital, and we have the second one over here, which leaves one of the unhybridized p orbitals sticking up like this, and another one, remember, coming out at you, out of the plane. This is our orbital arrangement for the sp hybridized carbon. Notice, in order for those electrons in the sp orbital to be as far apart from each other as possible, it means that those orbitals are going to be 180 degrees apart. But careful, the two p orbitals are only 90 degrees from the sp orbitals. So how does this help us understand how carbon triple bonds? Well, let's put it to work here. Remember, we said this is the layout of a carbon triple bonding. So let's place that carbon over here. Remember, he has his unhybridized 1s orbital here. But let's get rid of him so we could focus on the hybridized orbitals. Let's place both of our sp hybridized orbitals here. And let's pause for a second here. Notice I can head-on overlap with any orbital I want here, and that would create two sigma bonds, one on the left and one on the right of the carbon. So this explains the two sigma bonds. What about the remaining two pi bonds? Well, remember, he has the unhybridized p orbital sticking straight up like this, which means that can sideways overlap with another p orbital on another atom next to him. And since they're sideways overlapping, that would create this pi bond right here, or either one of them. It doesn't really matter. Now let's look at how the next pi bond is created. Well, remember, this carbon also has that p orbital sticking out at you here, which means an atom to the right of him would also have a p orbital sticking out, and these could sideways overlap this way. That would create the second pi bond. So let's look at an orbital picture of a simple triple bonded carbon molecule, acetylene, or sometimes called ethyne. Each carbon in this molecule is sp hybridized, So let's get a good look at that. The carbon on the left would have this particular orbital arrangement, and the carbon on the right would have this one. Notice between these two carbons is an overlap of both their sp hybridized orbitals. That would be the sigma bond between them. And look at the 2p orbitals that are vertical here. They would sideways overlap, and that would simply make one of the pi bonds. And so we can see this clearly. Let's get rid of all these other orbitals for a second and focus on just the 2p orbitals that are sticking out at you. They would sideways overlap, and that would simply make the other pi bond. So, putting this all together, we end up with this orbital arrangement. Notice the hydrogens on the end would head-on overlap with the sp hybridized carbons of the molecule, and that would create the other two sigma bonds. So, make sure you know for your next Orgo exam the exact orbital arrangement for an sp hybridized carbon. Remember, we must know the bond angles, we must know what the orbitals look like, and we must know the electronic configuration diagram underneath, including its relative energy levels, such as the 2p unhybridized orbitals are higher than the 2sp hybridized orbitals.